बेस्ड है? Last class we have done till stationary wave formation. See further. State the formula for velocity. State the formula for velocity of transverse wave and hence derive expression for frequency of vibrating string. Frequency of vibrating string. इशिका,
हाँ सर,
नोट्स भेज दूंगा मैं, हाँ देख लेना.
ठीक है सर.
Velocity of transverse wave and derive expression for frequency of vibrating string. Suppose this is string. Is it stretched or unstretched? String है ये, string. Stretched or unstretched? कौन सा string लग रहा है आपको?
Unstretched.
Unstretched.
अभी मैं क्या करता हूँ, इसके एक एंड पे ना, एक एंड को ऐसे रिजिड सपोर्ट में फिट कर देता हूँ एंड ट्राई टू अटैच वेट एट अदर एंड. इसको पैन बोलते हैं. इन दिस वी आर पुटिंग वेट. नाउ ड्यू टू दिस वेट इट विल गेट स्ट्रेच्ड. इट विल गेट स्ट्रेच्ड. नाउ इफ आई प्लक इट, मतलब ऐसा ऊपर जर्क दिया तो ऐसा ऐसा वेव आएगा. This wave will get reflected back. So incident, reflected wave interferes, we get stationary wave. Stationary wave means this wave will not move forward or backward. दो पॉइंट के बीच में खाली ऐसा वाइब्रेशंस रहते. They are called stationary waves. So when you pull this, by putting weight, tension is created along the string. Pulling force will give tension. The velocity of transverse wave, set up along stretched elastic, set up along stretched string. The velocity of transverse wave set up along stretched string is given by, heading was state, not proof, because proof is not there in our syllabus. Given by root of P by M, where T equals to tension along string and small m equal to mass per unit length of string. It is also called as linear density or linear density. So just write this statement. Velocity of transverse wave set up along stretched string is given by V equals to root of T by M. T is tension, M is mass per unit length or linear density.
Done, sir.
Okay. Hence derive expression for frequency of vibrating string. This is our heading. Now imagine this is one string fixed at 2 point. Its length is L. Here we will get node, means no vibration, and this way one loop is formed. इसको बोलते हैं loop or segment. In this case, I can say length of string is equal to distance between two nodes. That means 1 lambda by 2. Suppose string is vibrating with 3 nodes, then you can see there will be 2 loops. 2 loops. So here total distance is 2 lambda by 2 is length of string. If same string is vibrating with 3 loops, then it is 3 lambda by 2 equals to L. 3 loops. So it can vibrate with 1 loop, 2 loop, 3 loop, or P loop, we don't know. So I can argue like this. Consider a string. Consider a string of length L to vibrate with P loops. Therefore, distance of P loops, comma L will be P lambda by 2. So lambda will become 2L by P. Since V is L lambda for any wave, so I can say V equals to N into 2L by P. That is, V is also root T by M we got, equals to N into 2L by P. Therefore, frequency N is P by 2L root of T by M. This is formula for frequency of vibrating string. Clear? One string vibrates with P loop, so P lambda by 2, lambda is 2L by P. From that P is N lambda. V का दूसरा formula is root T by M. Just now we did. So by cross multiplying, N is P upon 2L root T by M. This is formula for frequency of vibrating string. Complete. Complete till end. This is formula for frequency of vibrating string.
Done, sir.
Sir, एक second.
हाँ.
हाँ डन सर.
State laws of vibrating string. State laws of vibrating string. First is called as law of length. So we got n equals to E upon 12 root of T by M. If we put P equals to 1, then it is called fundamental frequency of vibrating string. Fundamental frequency. Now, if I keep two quantities constant, then I will get relation between other two. If T is constant, M is constant, N and L का relation मिलेगा. M and L constant, then N और T का relation मिलेगा. Same way LT constant, then N and M का बीच का relation मिलेगा. So total we have three laws of vibrating string. First is law of length. From formula I got idea I should keep T and M constant. So I start like this. When tension T and linear density small m are kept constant, when tension T and linear density small m are kept constant, then fundamental frequency n is inversely proportional to the length of vibrating string, that is n proportional 1 upon L. This is known as law of length. First law clear? Very simple. T and M constant, n proportional 1 by L. This is known as law of length. Okay? Hello?
हाँ सर एक बार आप फिर से रिपीट कर सकते हैं सर, आजू बाजू में बहुत आवाज चालू था.
N is 1 upon 12 root of T by M. ये अपना फॉर्मूला है फ्रीक्वेंसी का. इन फंडामेंटल मोड T कांस्टेंट रखा, N कांस्टेंट, M कांस्टेंट रखा, तो ऐसा मिल जाएगा. ये इसको वर्ड में कैसा बोलो? When tension T, linear density M are kept constant, then fundamental frequency is inversely proportional to length of vibrating string. This is known as law of length. Okay? Vedant?
हाँ सर.
ठीक है, लिख लो अभी लॉ ऑफ लेंथ.
Sir, done.
Second point. Law of tension. Again same. When vibrating length L, comma, linear density small m are kept constant, then fundamental frequency of vibrating string is directly proportional to the square root of square root of tension along the string, that is n proportional root t. This is known as law of tension. This is known as law of tension.
Sir,
Okay, done.
हाँ sir.
Third page. Law of linear density. Exactly in same wording. This time L and T are constant. So when vibrating length L and tension T are kept constant, then fundamental frequency of vibrating string is inversely proportional to the fundamental frequency of vibrating string is inversely proportional to the square root of linear density, that is n proportional 1 upon root m. This is known as law of linear density. Right. As I told, chapter is simple, not very complicated. Completed?
Yes, sir.
Okay. So we got three law of length, law of tension, law of linear density. This only once they had asked like this. Show that fundamental frequency of vibrating string, so that fundamental frequency of vibrating string is inversely proportional to the radius of vibrating string. Inversely proportional to the radius of vibrating string. Since linear density small m is mass per unit length. Mass we can write density into volume. I think everybody knows density is mass upon volume. So mass will become density into volume. Volume of wire, if this is wire, its volume will be area of cross section into length. Upon length cancel. So m equals to density into area pi r square. Now we know that frequency is inversely proportional to square root of linear density. So we can say 1 upon root of small m is rho pi r square. Since rho comma pi are constants, therefore I can say n proportional 1 upon root of r square. So n proportional 1 upon r. Hence 2. Any doubt? Hello?
No, sir.
Okay. Just copy. This was asked once for 2 marks. Suppose ये लोग ने change कर दिया और बोला show that n proportional 1 upon root of rho. तो आप इधर बोलना फिर since pi r are constant, n proportional 1 upon root of rho. Okay?
Yes, sir.
Solve. Slowly, I think few colleges are starting. Before
सीनियर कॉलेजेस चालू कर रहे हैं.
नहीं पता नहीं, आज तो ये बोल रही थी मुझे अनुष्का, उसका ऑनलाइन लेक्चर चालू हो गया.
हाँ ऑनलाइन तो सर मेरा भी वो तो कब का चालू हो गया मेरा, और 1 महीना हो गया चालू होके.
अच्छा. For you all morning lecture, before this you all have any class?
हाँ सर, मतलब मंडे और वेडनेसडे को रहता है, इसके पहले फ्राइडे को नहीं.
हाँ सर, हमको भी होता है सर.
कितना बजे? 7 बजे?
नहीं सर, मतलब एक्चुअली क्या होता है, मतलब सर वो रिकॉर्डेड लेक्चर का वो लिंक आता है ना सर, तो वो देखना पड़ता है सुबह सुबह उठ के.
क्या चीज क्या आता है?
रिकॉर्डेड लेक्चर का लिंक सर 11:30 को लेक्चर होता है ना हम
हाँ हाँ
इसलिए
सर यही टाइम रहने दो सर, चेंज मत करो।
टाइम तो कुछ प्रॉब्लम नहीं।
नहीं सर, क्योंकि कैसा रहता है ना सर, मतलब कि सुबह थोड़ा सा सर घूम के भी आता हूँ सर, इसके लिए थोड़ा अच्छा लगता है सुबह अगर थोड़ा वर्कआउट वगैरह करके आया तो।
हाँ बराबर।
वजन काफी बढ़ गया है।
हाँ नहीं, सबका वही हालत हुआ रहेगा।
तो इसके लिए अभी कैसे सर इधर प्रीमाइसिस में जिम है तो वहाँ पे जाता हूँ।
पर अलाउड है जिम चालू किया आपके प्रीमाइसेस?
हाँ प्रीमाइसिस में सर, अभी क्या सोसाइटी में है तो कोई कुछ बोलता भी नहीं है। तो किसी को क्या करना है बाहर वाले को, इसके लिए जाके आता हूँ।
ओके
हो गया।
ओके ओके। व्हाट इज फंडामेंटल फ्रीक्वेंसी ऑफ वाइब्रेटिंग स्ट्रिंग का फॉर्मूला? नोट लिख लो फिर, अगर याद नहीं है तो नोट। फंडामेंटल फ्रीक्वेंसी ऑफ वाइब्रेटिंग string comma n equals to 1 upon 2l root of t by n. Please memorize this because frequently it will come. Fundamental frequency of vibrating string comma n equals to 1 upon 2l root t by m. नया टॉपिक स्टार्ट करता हूँ। कंप्लीटेड ना? I'm clearing this. Okay. Now, explain different modes of vibrating string. Explain different modes of vibrating string or explain that string vibrates with all harmonics. String vibrates with all harmonics. Right heading? Then draw this diagram. These are strings of same length. Don't change the length. First is vibrating with one loop. So here P equals to 1. Second is vibrating with 2 loop. P equals to 2. And third one is vibrating with 3 loop. 1, डॉटेड मतलब एक रिफ्लेक्टेड वेव है ABC. Here P equal to 3. Explain different modes of vibrating string, or explain that string vibrates with all harmonic. What is harmonic I will explain just now. Draw 3 diagram. Keep in mind length is same, खाली loops 1 2 3 ऐसा हो रहा है. If completed, please let me know. Yes, completed all the 3 diagrams.
Yes.
Okay. अभी जरा किसको बोलते हैं हार्मोनिक? Let us see. Integral multiple of fundamental frequency is called harmonic. That means if fundamental frequency is n, if fundamental frequency is n, तो 2n को बोलेंगे सेकेंड हार्मोनिक, 3n is थर्ड हार्मोनिक, 4n is फोर्थ हार्मोनिक. यानी कि मल्टीपल ऑफ फंडामेंटल is called harmonic. So see how to explain different modes. Mode means method. The different ways in which string can vibrate. The different ways in which string can vibrate are called as modes of vibrating string. Are called as modes of vibrating string. Case 1, fundamental mode. Case 1, fundamental mode. When string vibrates with one loop, then it is said to be in fundamental mode. Let n1 be the frequency in this mode. Therefore, n1 is 1 upon 2l root of p by m. This is called as fundamental frequency or first harmony. Any doubt? Hello? Any doubt in there?
No, sir.
No,
Okay. Just copy till this. Case 1 पूरा enter. Simple chapter है, but again and again I am telling regular studies must in 11th 12th science. Again, once you complete, please tell me.
Done, sir.
Okay. So far we have completed only case 1. There are 2 more cases. Case 2. Second mode of vibration. When string vibrates with 2 loops, then it is said to be in second mode of vibration. Let N2 be the frequency in this mode. Therefore, N2 will be 2 upon 12 root of T by M. So this 2 upon 12 root T by M can be written as 1 into 1 upon 12 root T by M aisa. So in this case, this is nothing but fundamental frequency. So I can say N2 is 2 times N1. This is second हार्मोनिक, क्योंकि फंडामेंटल का डबल को हम सेकेंड हार्मोनिक बोलते हैं, और फर्स्ट ओवरटोन. दिस इज न्यू टर्म फॉर फर्स्ट ओवरटोन. फर्स्ट ओवरटोन मीन्स वन एक्स्ट्रा नोड. लाइक दिस इज फंडामेंटल, इसमें 2 नोड है. दिस इज नेक्स्ट मोड. हियर आई कैन सी देयर इज वन एक्स्ट्रा नोड. हियर बीच में एक एक्स्ट्रा आ गया. तो डिपेंडिंग अपॉन एक्स्ट्रा नोड वी से ओवरटोन. तो टोन मतलब आवाज. अब ये एक ही लूप से आवाज कर रहा था, एक एक्स्ट्रा लूप दे दिया, तो इसको हम लोग बोलते हैं फर्स्ट ओवरटोन. आई हैव रिमेंबर्ड लाइक दिस. नंबर ऑफ एक्स्ट्रा नोड as compared to fundamental mode is called as overtone. Now just tell me, if this is fundamental, then this is which overtone? ये सब नोड बना है, नोड नोड नोड. ये फंडामेंटल है, तो ये कितना एक्स्ट्रा नोड है इसमें कंपेयर टू फर्स्ट वन?
2 एक्स्ट्रा नोड.
2 एक्स्ट्रा नोड है, तो इसको मैं बोलूंगा सेकेंड ओवरटोन. मीनिंग समझ गया ओवरटोन का? बाद में नोट
Yes,
में
sir.
लिखा दूंगा चाहिए तो. नंबर ऑफ नोड्स, एक्स्ट्रा नोड्स एज कंपेयर टू फंडामेंटल इज ओवरटोन. ये बुक का लैंग्वेज नहीं है, ये अपना समझने का लैंग्वेज है. बुक तो बोलता है ओवरटोन्स आर फ्रीक्वेंसीज अदर देन फंडामेंटल फ्रीक्वेंसी. मतलब फंडामेंटल के आगे ओवरटोन हो जाता है, बट ऐसा मंत्र से करेंगे तो नहीं मिलेगा. सो बेस्ट इज व्हाट? Number of extra node as compared to fundamental mode. This is how I will write in node. Again, say second mode. When string vibrates with 2 loop, then it is said to be in second mode of vibration. N2 be the frequency in this mode. Therefore, N2 is 2 upon 12 root T by M. That is 2 times N1. This is second harmonic or first overtone. Copy case 2. Moment you complete, please let me know again.
हो गया सर.
Okay, okay. Then write case 3. Case 3. Case 3. Third mode of vibration. When string vibrates with 3 loops, then it is said to be in third mode of vibration. In third mode of vibration, let N3 be the frequency in this mode. Therefore, N3 equals to 3 upon 12 root of T by F. So N3 is 3 times N1. Which harmonic it should be?
Third harmonic.
Third harmonic. This is third harmonic. Or which overtone? Second overtone. Thus, in general, the string vibrates with frequencies N1, 2N1, 3N1, dot, dot, dot. Therefore, it vibrates with all harmonic. तो एग्जाम में ऐसा भी पूछते हैं, show that string vibrates with all harmonic. This is third harmonic or second overtone. Thus, in general, string vibrates with frequencies N1, 2N1, 3N1, dot, dot, dot. That is, it vibrates with all harmonics. Now you can copy. In exam, they can ask, explain different modes of vibration or show that string vibrates with all harmonics. This completes one part of the chapter. गणपति है किसका घर पे?
हाँ सर.
अच्छा अच्छा, 2 दिन का है?
11.
11 दिन का.
हाँ सर.
First day is on 22nd or 23rd?
22nd.
तो मॉर्निंग स्लॉट नहीं रखता हूँ फिर. 22nd
सर
मंडे.
22nd सैटरडे है.
तो टेंशन नहीं, फिर अपना नहीं. That oscillation you have completed as per that planner? हेलो,
सर
ऑसिलेशन वाला वो प्लानर के हिसाब से कंप्लीट हुआ क्या आप लोग का?
10-20 बाकी है एमसीक्यू.
अच्छा ठीक है, वो कंप्लीट कर लो, फिर नया प्लानर देना है ना आज.
हाँ सर.
आज संडे तक का दिया है उसमें, क्या फ्राइडे तक का?
सर संडे तक का दिया है.
ठीक है, फिर मंडे देता हूँ, मंडे मॉर्निंग देता हूँ. देखो अभी आपको अपना प्लान को स्टिक करके रखना है, एग्जीक्यूट प्रॉपरली। इसी का थोड़ा अच्छा सम्स करो, क्वालिटी सम्स, क्योंकि आप मेन और के लिए तैयारी कर रहे हैं पूरा।
हाँ सर।
डन सर।
ओके, अभी खाली एक छोटा सा डायग्राम बना लेना, आज टाइम कम है ना। हेडिंग लिख दो, शो दैट air column, so that air column in closed pipe vibrates with only odd harmonics. Vibrates with only odd harmonics. So today we'll only draw the diagram. Explanation in the next lecture. Draw this pipe closed at one end. Three pipe you have to draw, same pipe actually 3 times closed at one end. Length L, pipe closed at one end having length L, same pipe we are drawing 3 times. Open end, here antinodes will be formed, and closed end always nodes will be formed. इधर vibrating tuning fork करते हैं open end पे, so that vibration होगा. Inside we are showing dotted line, this is vibration. एक एंटीनोड और एक नोड मतलब लैम्डा बाई 4 डिस्टेंस, दिस इज लैम्डा 1 by 4. Then one more extra node will come in between. Antinode to this node, distance will be lambda 2 by 4, lambda 2 by 4. Node, node. lambda 3 by 4, lambda 3 by 2, snap. Draw this diagram.
Done, sir.
Venn diagram. Next lecture we'll see is explanation on Monday. So Monday theory of this chapter will get over. And in Wednesday, Friday, numericals will complete. Then one more week MCQ. That means August, as I told, waves and oscillation we have to make perfect. September first week I will start with thermodynamics. That will take long chapter. It will take almost 1 month, I think. If it is completing earlier, again I will do few MCQs of heat chapter. So by September end, our part is A1 is completed. Then I will restart with again revision from first chapter onwards. That is from rotational dynamics. तो वो भी अक्टूबर तक पूरा रिवीजन खत्म करके टेस्ट सीरीज चालू कर. So be in touch. Follow that targets given properly. If it is beyond your reach, you tell me so that I can reduce that targets. But if you can manage it,